You and I have spoken before with Tim Mondlin and then Sean Carroll about quantum mechanics and its theories or interpretations, but I don't think we've ever talked explicitly about the metaphysics of quantum mechanics. And I think a good place to start before we get into maybe the meat of a guess at the riddle is what some of the core metaphysical questions are about quantum mechanics and why it is that only more recently these questions are being asked again.
Right. I mean, I'm not sure there's a very sharp distinction between what you were calling interpretations of quantum mechanics and what you're calling the metaphysics of quantum mechanics. But the idea is roughly this. In the beginning of the 20th century, when quantum mechanics was first being formulated, when these very, very strange behaviors of subatomic particles were being experimentally discovered, and when people were struggling to make sense of these behaviors and of issues like the stability of atomic matter and so on and so forth, quantum mechanics was developed by a circle of people who were in many ways intellectually centered on Niels Bohr in Copenhagen. A theory was developed that these people claimed very influentially, and convinced everyone, was not amenable to any realistic understanding. Okay. That the only coherent way to approach this theory was in a radically instrumentalist way, that the theory was a mechanism, that the theory was a recipe or an algorithm for making predictions about the results of experiments, and any attempt to correlate the symbols in the theory with things that were going on under the table, things that were really going on in the world in between these experiments that could give us an account of why the experiments were coming out the way they did. Any such realistic aspirations were declared by Bohr and the circle of people around him to be, any such aspirations were declared to be hopeless. Any attempt to pursue these aspirations were going to collapse into paradox and contradiction and so on and so forth. It is, thinking back on it now, pulling back on it by 100 years, the idea that people somehow convince themselves that the outcomes of certain experiments, the positions on pointers of various measuring devices, somehow entailed that that there wasn't a world out there that could be captured in realistic language. It's astounding to think nowadays that people talk themselves into a position like that, but they did indeed. And the person at the center of these developments, Bohr, was apparently a sort of breathtakingly charismatic figure. If you read Bohr, if you read the kinds of arguments for this position that Bohr attempts to write down on paper, it's impossible to make sense of them. It's really impossible to make sense of them. But his effect on people that he spoke to in person, his effect on smart people that he spoke to in person, was astounding. People would take a walk in the woods with him for a half an hour and their lives would be changed. And he inspired enormous intellectual loyalty and intellectual reverence among some of the smartest people in the 20th century. Anyway, for all these reasons, there was a very strong prejudice in physics about quantum mechanics, that quantum mechanics in some very decisive way represented the end of the scientific project as it had previously been construed, okay? Where it was a project that was aimed at providing us with a more or less literal, more or less naively realistic picture of how the world worked. And a picture that was going to be fit then to be a guide to doing metaphysics, okay? A picture that was fit to at least be a starting point to read our metaphysics off from. And the effect of Bohr and his circle, and like I say, this was a circle of people who quickly convinced the entire community of theoretical physics. The effect of this was to declare that, on the contrary, if there was a project of metaphysics at all, physics wasn't going to have anything to contribute to it, because physics was just not in the business and could not be in the business of providing, of offering anything like a literal, flat-footed, traditionally realistic sort of picture of what was going on in the world. Good. This general mood in theoretical physics persists for more or less a century. There's a lot of stories to tell about how it was maintained for that long. It involved a lot of real sort of, on a professional and intellectual level, brutality. People who were interested in these questions didn't get jobs, were dismissed as nuts. Even figures like Schrodinger and David Bohm, and especially and particularly Einstein, who raised objections to this, who said that they didn't see how these anti-realist arguments worked, who were interested in developing a realistic understanding. These people were responded to with dismissal, with gibberish, with purported answers to them that weren't really answers to their questions at all. This prohibition on thinking along these lines was enforced with a very, very heavy hand throughout much of the 20th century. A lot of your viewers probably recently saw Oppenheimer over the summer. One of the things that's going on off screen in Oppenheimer that never really gets explained, but has a few consequences on screen, is the position of Einstein in physics at the time of the Manhattan Project. There's a scene, I think, early in the movie when Oppenheimer is being shown around the office he's being offered at the Institute for Advanced Study, and they see Einstein out the window. And the guy who's showing him around says, I never understood why you didn't involve Einstein more in the Los Alamos project. After all, Einstein is the foremost, the foremost thinker about physics alive. And Oppenheimer responds kind of mysteriously in the movie, well, he was the foremost figure. It's been, it's been 40 years or so since the guy really did anything. That's not true. What the guy had been doing during those 40 years was raising objections to the attitude of Bohr and his circle about quantum mechanics, and even such a sort of towering figure as Einstein could be ostracized, could be turned into what Einstein used to refer to as a museum piece, because of the sort of brutality of the insistence that nobody challenged this dogma of Bohr's, that the realistic, that physics needed to accept the end of its realistic aspirations. Okay, good. like I say, there's a long, interesting story about how this was enforced. It involves, one could write a sort of underground intellectual history of the 20th century just by following this debate out. I mean, it involves the rise of modernism. It involves the McCarthy period in the United States. It involves all kinds of interesting stuff. There's a nice book about it that I recommend to your viewers if they're interested in this history, that came out a couple of years ago by a guy named Adam Becker. It's called What is Real? I think the title is kind of goofy, but I think the book is quite good. Anyway, to get around after a lot of circumlocutions to your question, I would say in the last 30 years or so, a number of philosophers of physics and physicists have finally very powerfully, very clearly made the case that Bohr and his circle were completely wrong about this, that their arguments that any attempt to produce a realistic interpretation of quantum mechanics was bound to collapse into paradox and self-contradiction, and so on, was shown by means of producing a number of explicit constructive counterexamples to be false. So what, if somebody wakes me up in the middle of the night and asks me to summarize in one sentence what happened in discussions of foundations of quantum mechanics over the past 30 years or so, the sentence would be, look, the possibility of a realistic understanding of quantum mechanics has now been decisively put back on the table. The arguments that had carried so much weight for a whole century to the effect that such a naive, realistic understanding was impossible have been decisively, clearly, concisely refuted to everybody's satisfaction. And now the project of trying to use our best physics as a guide to our metaphysics is at least back on the table. One may have had doubts from the beginning whether physics should be a good guide to metaphysics or not, but if you were inclined to think that a good metaphysics ought at the very least to be very deeply informed by our best available physics, that was now back on the table as a coherent possibility. Let me say in a little more detail what went on. The thing that the Bohr's argument that there couldn't be any such thing as a naive, mechanical, realistic understanding of the experiments that quantum mechanics described centered on a particular problem, centered on a particular paradox, which came to be called the measurement problem. Okay, that it was, that there was some very important idea that quantum mechanics, and quantum mechanics being the most fundamental contemporary approach to physics, physics itself required, before you got started, cutting the world up into a part that is observed and a part that observes. Okay, and if you tried to give a complete description of the world within your physics, that is, if you tried to push everything to the side of the observed, okay, into the collection of things that the physical theory is supposed to describe, the theory would implode, the theory would collapse, blah, 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 blah. So there was supposed to be this obstacle to a traditionally realistic, comprehensive description of the world that had to do with the act of measurement, and that came to be called the measurement problem. What happened over the past 30 years is that arguments were made that, and so this problem, let me just back up a little bit, this so-called measurement problem was absolutely not thought of by Bohr and his circle as as something in the nature of a scientific problem, okay? As something that it was going to be the task of physics to solve, okay? It was something quite different, of a quite different kind. This is where physics came up against the limits of the scientific comprehensibility of the world. Okay, this is where physics came up against the limits of the kind of project that it had always been engaged in. This was the direct encounter with the ineffable, or something like that. Okay, so the measurement problem didn't represent something that anybody should work on or anything like that, and it was considered a sign of naivete, of intellectual immaturity on the part of people as august as Einstein and so on, that they thought that what you should do with this is try to solve it. Okay, good. A number of people working mostly, whose work was mostly ignored, did in fact present solutions to the measurement problem. People like David Bohm in the 1950s, people like the Italian physicists Gherardi, Rimini, and Weber in the early 1980s. What happened in people maybe like Everett, also like you, Everett, in the 1950s? Whether Everett really achieved the solution to the measurement problem or not is a debate that I've had on your show with Sean Carroll and so on and so forth. But anyway, there were a number of people whose work wasn't paid very much attention, who did explicitly, by counterexample, show that Bohr was wrong. They wrote down coherent solutions to this problem, coherent ways of thinking, of allowing oneself to think that quantum mechanics amounted to a complete description of the physical world, including the process of measurement, including the measurer treated as an ordinary physical object, and so on. Good. These things happened. Nobody paid much attention to them. Bell, I think, inspired a generation of people closer to my age to look at these proposals seriously, to see that they really did provide decisive, constructive counterexamples to the doctrine of Bohr and his circle, and that they refuted what was announced as this huge discovery in the beginning of the 20th century, that the days of naive realism about what science could do were over. Okay, good. So a number of people wrote down constructive, explicit solutions to the measurement problem, at least insofar as the simple versions of quantum mechanics, non-relativistic, so-called first quantized versions of quantum mechanics go. And I think what happened over the past 30 years or so is that a bunch of people thinking about the foundations of physics took these counterexamples, investigated with them, worked with them, were able to present a very, very decisive case that this problem, which was supposed to be the great obstacle to a realistic version of quantum mechanics, could be solved. Okay, that in fact it was an ordinary scientific problem, like other scientific problems. And what you needed to do in order to solve it is make certain explicit physical, mathematical changes in the quantum mechanical formalism so that it wasn't burdened with this problem anymore. So ironically, the contribution of philosophers here was to insist that a certain problem which Bohr had wanted to insist was a gigantic philosophical problem about the fundamental ineffability of the world was in fact an ordinary scientific problem, okay, which is exactly what Bohr had been denying it was. Once you've got this, once you've got several proposals on the table for actually solving this problem, once you have several proposals on the table for an actual internally consistent mathematical framework of a theory which was clearly susceptible of a realistic interpretation, then the question can again arise, and finally did arise, I would say about 25 or 30 years ago, in a serious way, in discussions of the foundations of physics. A question can then arise about what the appropriate realistic interpretation of this theory is, what this theory is in fact telling us about the structure of the world, about the natures of these subatomic particles whose behaviors are so strange, about how it is that matter manages to stay stable, even though classical physics would have predicted its almost immediate collapse, so on and so forth. So you've got a chance to treat this theory again, as lots of people were treating physics toward the end of the 19th century, okay, as the sort of royal guide to metaphysics, okay? Maybe it wasn't all there was to metaphysics, but it was something that was going to be a great aid to metaphysics. It's one of the places where metaphysical speculation about the structure of the world ought properly to start, okay? And this business got up and running again, I would say about 20, 25 years ago. Ironically, there were a whole bunch of people, like I say, people of around my age, people like Tim Maudlin, people who you've had on your show a lot, people like Barry Lower, lots of people who were interested in the foundations of physics. There were a bunch of people who were absolutely in lockstep with one another, who were finishing one another's sentences when it came to giving these arguments that that Bohr's position was wrong. Okay, and as soon as it felt like that job had been adequately done, we found that we had very different intuitions. Now that the possibility of entertaining a realistic interpretation of quantum mechanics was back on the table, now that this measurement problem, which was supposed to be the great impediment to such an interpretation, had been taken out of the way, now that we were free to say to ourselves, good, what does this theory seem to be telling us in a sort of naive, realistic way about the structure of the world? It turns out that people who had been involved in arguing that the measurement problem was a scientific problem and had a scientific solution ended up with very different intuitions about what the theories we were left with suggested about the basic metaphysical structure of the world. And what I mean by the basic metaphysical structure of the world, and this is finally, at very long last, getting back to your original question, what we mean is questions like what the fundamental physical systems are, okay? What the fundamental physical ontology of the world is. That's the question that a lot of these debates have been around, and also associated questions about what we should think about phenomena like what we should think about principles of locality and phenomena of non-locality, which I'm happy to go into later on if you'd like. But the basic metaphysical question is the standard one. What's the fundamental ontology of the world? What's the stage which we used to think was three-dimensional space and time, on which that ontology parades around. What's the stage on which the fundamental history of the world unfolds? Those are the sorts of basic metaphysical questions that people are thinking about.